The purpose of this project was to create an LED light strip that's Wi-Fi connected, that utilizes open source software and mostly open source hardware. The difference between this project and LED light strip products that might exist in the market today is that those products primarily use smartphone app-based user interfaces that are tied directly to the operating system. This will use a web browser, so any device that has a web browser can be used to control these LEDs. The website is hosted on a Raspberry Pi web server, which also hosts an MQTT broker. The website uses WebSockets to communicate to the broker, which then sends via MQTT communication protocol a command message to the Node MCU Wi-Fi chip, which is physically connected to the Arduino Mega. The communication between the Node MCU Wi-Fi chip and the Arduino Mega happens via software serial. That message then is translated on the Arduino Mega into a light show, which is then displayed on the LED strip. Here's the Raspberry Pi that hosts the web page and the MQTT broker. It's connected to Wi-Fi via a Wi-Fi dongle. The project uses generic 5-volt power supplies, which supply power to the LEDs and the Mega separately. This is the Node MCU that receives the signal from the Raspberry Pi. This is the logic level converter, which converts the 3.3 volt logic to 5 volt logic to work with the Arduino Mega. The Arduino Mega takes the commands and sends it through a pretty long wire up to the LEDs on the ceiling. This light show is the juggle light show, which I'll show you again a little bit later. I'll show you a quick demo of the website. Now you can see it automatically connected. We can click this down arrow and disconnect if we choose to, and it will connect back up. The commands for the light shows are all in this drop down menu here. So this shows the different names of the light shows, and we can select whichever one we want. And we select play, and it'll show on the light show. This can be minimized as well. For this demonstration, I wanted to show some of the underlying communication that happens when the play button is clicked on the website. So I have the website on the right, and on the bottom left I have the Node MCU. So we should see when a button is clicked on the website, we should see that message get sent to the Node MCU via the Raspberry Pi. At the top left is the Arduino Mega. So when the Node MCU gets its message, it should translate it and send it to the Arduino Mega, which will send it out to the lights, which show up on the bottom right, and we should see the light show displayed there. Okay, so here I click play, and on the Node MCU you could see that scroll up through there. And here I'll select all and click all. And here you can see the command on the Node MCU gets sent to the Arduino. So that should start showing on the LED display. However, there's some issues with all right now, and so it won't show up. So we'll move on to the next one. Okay, rainbow, and click play, and you see it on the Node MCU, and there we go. Now it's running. So rainbow just runs through all of these colors and does a slow cycle. And the next one is rainbow with glitter, which runs similar to rainbow, except it'll add extra flex. And it looks like there was a little problem there. Not every click works. Almost all the time it does. So here we go as rainbow with glitter, and you'll see little specks of white light run through the rainbow light show. And this next one, confetti, you can see ran through just fine on the first click. There's a slow fade from the rainbow with glitter into confetti, and it just randomizes random colors and random lights. And next up is sine lawn, which uses a little bit of math. Oh, looks like it didn't quite work this time. So we'll click it again. And there we go. So a little bit of math, and it just runs this light back and forth from beginning to end. And juggle seems to be the favorite of many. This one is essentially sine long, but runs multiple LEDs through at a somewhat random interval. And BPM, it doesn't look like it made it all the way to the Arduino this time. We'll do one more click on it. Okay, there we go. And BPM just takes some of the colors, does this back and forth motion with them. This can be adjusted in the code, but right now I don't have it adjustable on the website. And we'll take it back to off, and it'll slow fade out. Thank you very much.